So hi guys, welcome back to YouTube channel Unknown IITians. Hope so all you are doing great. In this lecture we will study about statistics week 2. So let's move further. So the first topic is frequency distribution, and frequency distribution is a type of representation which is either in a graphical way or a tabular format, alright, that displays the number of observation within a given interval. So its main feature is to display number of observation within a given interval. Alright, so now the frequency is how often a value occurs in an interval, and distribution is the pattern of the frequency of the variable. Suppose we have a data set here that is A, B, C, D, A, D, C, B. Alright. So here, to make the frequency distribution table for this data set, first of all we will need a table with 3 columns. So first column will be categories, second will be frequency, third will be telemark. So now we have 4 categories here: A, B, C and D. So frequency is how many times a value occurs in the interval. So we will count A first. So we have 1, 2, 3, 4, 4A. B we have 2, C we have 3, and D also we have 3. So this will be 4, 2, 3 and 3. So now if we add all of the frequencies, we will get the total number of observations. So if we add them, so this is 6, 10 and 12. So there are 12 observations here. So now let's check here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now we can see that this frequency distribution table is correct. Alright, so this is how you represent a frequency distribution table. You can see this example too. In this we have number of cars manufactured in the interval, and we have total cars manufactured, name of the car companies here. So these are the frequencies. Alright, so now the second term is relative frequency. So what do you mean by relative frequency? Relative frequency is equal to frequency of particular category upon total number of observation. All right, so now here are two important characteristics of relative frequency. So first is it helps in comparing two data sets, and its value always falls from 0 to 1, and it can't exceed 1. Alright, so here we have an example. We have number of tosses, number of heads and relative frequency. So in a toss there are two cases, that is heads and tails. Alright, so now these are the two categories of toss. Alright, so now toss is the total observation. Alright, so this is the total, so this is the category. Now we have to find out the relative frequency. So for this, frequency of particular category is 4 here, so 4, total is 5, so this would be 0.80. Now here Particular category frequency is 6, total is 10, 0.60. 23 is particular frequency, 50 is total, 0.46, and similarly 49 upon 100 is equal to 0.49. So alright, this was how you calculate the relative frequency. So let's move further. So now we have pie charts. So pie chart is a type of graph representing data in a circular form, with each slice of the circle representing a fraction of proportionate part of the whole. So like here we can see that blue represent toys. Let me change the color of the pen. This represent toys, this represents furniture, home decor, and electronics. So this is the representation of the slice of the circle. All slices of pie add up to make the whole equaling 100% and 360 degrees. So now suppose we have a circle, a pie chart you can say, and it is divided into 4 equal parts, and each part have 25% contribution. All right, so if we add all of them, it's giving me 100%. Similarly, if we add all the percentage, I will get 100% equivalence. Alright, so here we have 28, 14, 15, 43. If we add them 12 and 8, that is 20, 4, 5, 6. 6 plus 4 is 100. I mean 10, and total makes it 100. Alright, so this is what 100% gives after equaling the percentage of the slices. Now there are two important things for pie chart, that where it is used. So it is used to show the proportions of the categorical variable. The pie chart is a good way to show that one category makes more than half of the total. Suppose here furniture is making half of the total. All right, so now here comes the bar chart. We also call it the bar graph or the column chart. So here it plots numeric values for levels of the categorical feature as bars. Bars are called this. These are the bars. Yeah. So these are the bars. Wait for a second. Yeah, so this is how a bar is represented. Alright, so levels are plotted on one axis chart and the values are plotted on the other. So here are the levels, and here are the levels, and here are the values. Each categorical value claims one bar. So a central category holds this bar, east holds this, south holds this, and west holds this. Alright, and the length of the bar corresponds to the bar value. So you can find it as the important point. The length of each bar corresponds to the bar's value. Alright, So let's move further. Here are the properties of the bar graph, and so it shows that bar graphs are unique and are very different from the other graph. Alright, so here comes the first point. The rectangular bars in the bar chart can be drawn horizontally or vertically. So this means if we have a graph here, it can be made horizontally or vertically. Alright, so this is vertically and this is horizontally. Alright, in a bar chart, horizontal or vertical column bars should have equal width and space between them. So here we should have this equal width, and here in between both of them we should have equal space. Alright. So the next point says that the height of the rectangular bars in a bar chart is equivalent to the data it represents. So if we have a graph here, alright, and we have the data here. So according to these values, it will make a bar graph, and this bar graph will be equivalent to the given data. Alright. The next point says the bar graph has two axes, x and y axis. So we have a data here and we have bars fitted here. Alright. So this is y axis and this is x axis. And a bar graph has two axes, x and y. Alright. The bar chart has labels on axes, the title of a bar chart, the scale, and the names of the axis. Alright, so here we have the name of the axis, x and y. We have the scale, that 1 unit is equal to 20 centimeter, suppose. Alright, so here will be a difference of 20 centimeter scale. Alright, here are the labels. If we represent that, this represents central, this east, west, and north. Alright, so this is how it is different and unique from other graphs. Alright, so let's move further. We have the area principle. So displays of data must obey a fundamental rule called the area principle. So we follow a fundamental rule while making a bar graph, that is area principle. So the area principle says that area occupied by a part of the graph should correspond to the amount of data it represents. As I earlier told you that as I earlier told you this point, that the height of the rectangular bars in the bar chart is equivalent to the given data it represents. So same point is here. Violations of the area principle are a common way to mislead. So what are the common way of mislead? Violation of area principle. So this is how you correctly represent a bar chart. Second is misleading graphs. So decorated graphics. Charts decorated to attract attention often violate the area principle. No baseline, and the chart shows bottles on top of label boxes of various sizes and shapes, always area principle and accurate. See, like in this bar chart, we can see that the value is starting from 0, it is correct, but here between 0 to 50 we have another value and that is not defined. Similarly here, and we are not having the exact measurement here. So This is not the right way to represent a bar chart. Here it is starting from 0. It has equal width and equal space between them. Alright, we have the x's, we have the labels. So this is how you represent a bar graph correctly. So now here misleading graphs, another point is when the baseline of the chart is not at 0, left graph exaggerates the number coming from south to north. Graph on right shows the same data with the baseline at 0. In the previous example, we see that it was starting from 0. Alright. So now in this we can see that here it is not starting from 0. So this is the wrong way. We should always start the graph from 0, 0.0, 0, points. Alright. So here are some examples. So now we have the expenditure of the month of October of manufacturing companies is shown in the figure 2.1a. Means here if 50,000 was spent on shipping, what was the total expenditure of the October? So now we have 50,000 rupees spent on shipping. That is green zone. Alright. So now here we can see that this is shipping and it takes 5% of the total expenditures. So that means 5% of expenditure is equal to shipping. Alright. So now let's suppose the total expenditure be X rupees. Alright. So now if we see according to this unit, that is 5% of X is equal to rupees 50,000. Alright. So now we will solve this here. So this will be 5 upon 100 into X is equal to 50,000. So X is equals to 50,000 into 100 upon 5. So this will be 10,000 and this will lead to 1000 10 lakh rupees in total. So its answer will be C. Alright. Next question. Next question says that choose the correct statement on relative frequency. So the first statement says that the ratio of the total frequency to the total number of observation is equal to 1. It means the same thing. Alright. So this will be a no. Sum of all the relative frequency should equal to the 1. It is not correct, as we have seen that all the values false between 0 to 1. So this is also a wrong statement. Now let's see the third one. The ratio of the particular observation to the total number of observation is the frequency relative of that observation. So this is correct, as I already told you that C point says that relative frequency is equal to the frequency of a particular observation upon total number of observation. As I already told you earlier in the slide of relative frequency, that this is the formula, and this same is written as it is there. So that point is correct. So this point is correct. Now the fourth point, the multiplication of the total number of observation and the relative frequency of a particular observation should be equal to the frequency of that observation. It is saying that total D part, total number of observation into relative frequency is equal to the frequency of particular observation. So according to this formula, this statement is correct. So this point is also correct. So its answer is option C and D. C and D. All right. So let's move further. So the question says that Rajdhani trains connect the national capital of India with state capitals of India and or the biggest cities of the state. Rajdhani Express 12437 running from Sikandarabad Junction to Hazrat Nizamuddin Junction has one AC first class coach 1A, 5 AC second class coach 2A, and 9 third class coach, that is 3A. Each of the 1A, 2A and 3A coaches has maximum capacity of 18 berths, 48 berths, 64 berths respectively. So we can make a table here, that is coaches maximum berth and occupied berths. All right, occupied berths. So now we have 1 AC coach, 5 2A coach, 9 3A coach, and now each berth have 18 berth, this has 48 berths, and this has 64 berths. So that is 1 into 18 is equal to 18. 5 into 48 is equal to 240. All right, 240, and here 9 into 64 total berths are 576. All right, now here if we see further, on the given day 10 1A berths, half of the 2A berths, half of 2A berths, and 275 3A berths are occupied. All right, so here according to the first question, it says that what is the percentage of the berths filled in the train on the given day. So percentage filled is equal to percentage filled wait for a second, yeah, is equal to, this is A part, let me name it A part, first part, sorry. Alright, so percentage filled is equal to the total berths occupied and maximum total berths. So if we make the total of this, we have a column here called total. So if we add all of them, that is 576 plus 240 plus 18, we will have 834. Alright, and here if we add all of them, that is 120. Okay, so plus 120 plus 275 is equal to 405. Alright, so according to this into 100, so according to this it will be 405 upon 834 into 100, and this is equal to 48.5%. So the first question's answer is 48.5%. Now the second question says that what is the relative frequency of 3A berth among the total unfilled berths in the train on that day. So you have to find out the relative frequency of the unfilled berths. So now unfilled berths for unfilled berths for 3A coaches is equal to total 3A coaches, or sorry, total 3A berths minus occupied berths, occupied 3A berths, right? So this will be 576 minus 275 is equal to 301. Now total unfilled berths is equal to the total berths minus the total filled berths. So this will be 834 minus 405, which is 429. Now the relative frequency for, wait for a second, alright. So now the relative frequency of unfilled 3A berths will be unfilled 3A berths is divided by total unfilled berths. So this will be equal to 301 upon 429 and this will equal to 0.70. So the relative frequency is 0.70. If you want to check that it is correct or not, I already told you that relative frequency always lies between 0 to 1, and it is lying between 0 to 1, so it is correct answer. Alright, now let's move further. So here we have 43 chosen jerseys size are arranged in ascending order of sizes. So jersey sizes. Alright, if player B knows that his jersey size is approximately equal to the jersey size of the player with the 22nd ranked jersey player in this arrangement, so that means there is a player B. He says that his size is same as the 22nd ranked jersey in the arrangement. Same size, same jersey size of 22nd ranked jersey size arrangement. Alright, so if we find out the mode, it will not be applicable here. Now we have only the median. So if we find out the median, 43 is an odd number, so that is 43 plus 1 upon 2 according to the formula n plus 2 n plus 1 by 2. Alright, according to this formula, we will find out the 22nd jersey size is the median. So here, if 22nd jersey and player B, so if 22nd jersey size is small, then players B size will also be small, and if it is medium, then the player B size will also have the same size, that is medium. So if size M jersey, if it is a median of the size of the jerseys, it is correct. As I already told you, if his size is M, then player B will also have the same size. And similarly, if we see for the small size, it retains the same. So the correct answers will be C or D. Answer option C and D. Alright. Now let's move further. So here we have players MOM awards, that is frequency, and we have relative frequency column. Find the values missing in the table. Alright. So in this, for the first player, that is player number 10, we have both. So according to this, let me make a partition here. So for player B, for player 10, frequency is 76, that is 76. We don't know the total. Alright, so let it be total frequency Bx. Total frequency Bx. Alright, so we have the particular category frequency, that is 76. We don't know the total, and we have the relative frequency. So according to this, if we solve for x, so x will be 500. Alright, and now let's move further. We already know that 500 is total. Now for player number 3, player 3 is equal to 58 is its particular frequency, and total we have 500, so this will be 0.116. So this will be 0.116. all right. Now for the player 4 we have only relative frequency and we have to find the particular frequency. So player 4 is equal to, we have x 500 equals to 0.114. So from here x will be 57. So this will be 57. As this is 57, the values are same, so its relative frequency will also be same. Alright. Now for player 2 we will find it in the end. Let's come to the player 9. Player 9 is equal to, we have 43 as the particular frequency. 43 upon x, sorry, 43 upon, we know the total, that is 500, is equals to x. So here x will be, or you can write relative frequency RF. So RF will be equal to 0.086. Now similarly for player 1, player 11, player 6, player 5 and player 8. So we will solve the relative frequency similarly to the player 9. So here we have 42 divided by 500 equals to RF, that is 0.084. So this is 0.086, 0.084. 41 upon 500 is equals to RF. RF means relative frequency. I'm writing here RF is equals to relative frequency. So this will be equal to 0.082. Values remain same, so relative frequency will also be same. All right. So this will be 0.082, 0.082 and 0.082. Now for player 8 we have 25 upon 500 is equals to RF, and this will be equal to 0.05. 0.05. So now for player 2. So now for player 2 we all know that we have 500 total frequency, right? Let player 2 be x. Now if we add all of them, all the frequencies, sum of all the frequency, so this will be 500 is equal to 481 plus x. Alright, so now this x will be equal to 19. So here player 2 frequency is 19. So now if we calculate the relative frequency, RF is equal to 19 by 500, that is 0.038. So this is 0.038. So this is how you calculate this question. All right. So now let's move to the next slide. So this was all about the lecture for week 2 statistics. Hope you all enjoyed the lecture, and if you have any doubt, just comment in the comment section below. Thank you everyone.